All right, welcome to part 2 of the random number generator. The previous video, we went along with the combinational logic, and in this video, we are going to install the sequential logic circuit. So you guys should have gone through, built this entire circuit, started the simulation, and then filled out the entire chart for all the different LEDs, making sure that your LEDs are in this configuration so that they are in the correct order. And then you also should have figured out why 000 and 111 may or may not make sense in relation to the face value of the simulated dies. So what we're going to do today is make the sequential logic portion of the circuit. We are going to need 2 power sources. We'll need 3 D flip-flops, and make sure you configure those in the active low position. They're not that way by default, so make sure you change them. An SPDT switch, 1 ground, 3 digital probes labeled A, B, and C, an inverter, and 2 input AND gates. So let's go ahead and get over to the circuit. Again, so first thing that I'm going to do when I launch my circuit is I'm going to name it. And this one is still a part of 1.2.7. And again, it's still the random number generator, but this one is the sequential logic portion. I go over and do my regular thing, click the gear icon, go down to 200 by 200 and remove net labels. I'm going to go ahead and place my ground. I'm going to go ahead and use 2 VCCs. I'll find my 3 D flip-flops, my SPDT switch, and I'll flip that upside down. I'll add my inverter, and I'm going to flip that one backwards too, because on this circuit, if we face them to the right, things are going to get messy real quick. So I'm just going to go ahead and face that one to the left. I'll find my 2 input AND gate and flip that as well. And then I'm going to duplicate that. I'll add my 3 digital probes, and I'll label them A, B, and C. Let's go ahead and wire everything up. I'll connect ground to the first input of the SPDT switch, as well as our first VCC. I'll go ahead and connect the clock to the first flip-flop under the clock input. Now the wiring here is pretty important. Just make sure you don't mix this up. You need to connect power to reset on the first flip-flop. And one thing about the flip-flops that we pretty much always need to do is we need to configure them in the appropriate configuration. In this case, we're going to configure it to active low, and we'll do that for all 3 of our flip-flops. We can go ahead and start wiring up. We'll put ground to the first input of the SPDT switch. We will connect our first VCC to the second input, and our output will go to the clock of the first flip-flop. The second VCC, it's important to make sure you get this correct. The first input is going to go to reset on the first flip-flop, and then the other output of VCC will go to set on the second 2 flip-flops. We'll go ahead and connect our not Q to the clock of the second flip-flop, and then the not Q from the second flip-flop to the clock of the third flip-flop. We're also going to connect D back to not Q as well on all 3 flip-flops. We'll connect the output of our inverter to the 2 reset inputs on the second 2 flip-flops. And then we're also going to connect that to the set of the first flip-flop. We'll go ahead and connect our AND gate to the inverter. We'll connect our second AND gate to the first input of the first AND gate. And then we'll go ahead and connect our probes. And also for these probes, I'm going to go ahead and turn off instantaneous mode so that we don't see those on and offs, because we can see them visually anyways. And it'll also make it look a bit more clean. So let me remove those. We'll connect our first AND gate to A, create a junction with the J key. Our second input of that first AND gate is going to go all the way up to B. We'll make another junction. And the second input of the second AND gate is going to make its way up to C. We are also going to connect the first output, Q, of our first flip-flop all the way over to C. Our second output is going to go over to B, and our third output is going to go to A. And that is your completed sequential logic section for the random number generator.